So welcome for today's lesson. So today's lesson will have interesting topic which is limiting the reactant or limiting the agent. That is our today's lesson. So limiting the reactant. What is it? So you can have they'll give you like example of two concentration. Let's give in form of concentration. So this is a concentration, right? Or you are combining something. You are combining or you are making something here. You have this is solution A, then this will be your solution B. Now, in the process of combination of solution B, solution A, you are making solution C. Now, you are making solution what? C. Now, in the process of your combination of solution A and solution B to make solution A, it should have equal amount so that it can make solution C. Now, what if the solution here, which supposed to be combined, it is limited? Can you form more solution C? No, you can't. Yes. So solution A, B. So solution B, if it's solution B is limited, example, I'll give an example here. This is solution B. Then you have main solution like A. Then they tell you that to make solution C, you need to add some drops. Then you combine with solution B. You combine with solution B like A. Now, you have combined solution A and solution what? B. The solution is limited. The solution for B is what? Limited. Then it will limit also the product for solution C. What do I mean? So I said, if you have this is solution B, right? Then if solution B is limited, you are combined with solution A. You have left over for solution A and you have more what? Solution B. So if you are forming solution C, here solution B. So if you are doing like this practical or practicals in the labs, you will do some practical in the lab. So if this is solution B, right? You put here to make solution A. You put solution B. All solution B you put in. Then you put some solution A. Now solution A there are many. Then you need to measure. You measure some solution B. Then you put A. Then you combine. Then solution B. All solution B will just what? It will remain empty. But solution A, because it's many, it will remain some for solution A. Then solution B, because the solution has finished. Yes. So this means that to make solution C, the grounds for this solution C, it depends on solution what? Solution B. Because solution B is small, then solution A is what? It is many. So similar to what we are learning today, limiting the reactant. We'll learn how we can calculate the reactant in forms of grams, which is mass. Now, what are the things you need to know on limiting the reactant? Yes, the things which you need to know, we'll start with moles. This is simple because even moles, that is the only key thing which you need to know. Just moles. Because since grade 12 we are learning about moles. Even here even university level, you are learning about moles. So moles, it is simple and easy. Remember when you are going to study for chemistry exam study, the introduction part for limiting reactant, it says that limiting reactant, it is simple like drinking water. I like that. It says limiting reactant, it's like drinking water. That's what it has been compared, because it is simple. Anyone can drink water. You just get a cup and then you drink. So similar to limiting reactant, it is simple. The only thing which we need to know is moles. So moles, when you are measuring in chemistry, we just use the moles. So the formula for moles is equal to mass over Mr. Yes, that is the formula for moles. This is a mass, or moles is equal to mass over Mr. Right. Now, how can you relate? How is it related to limiting reactant? Because they will give you questions. Remember what they told you? Yeah, let's go back to grade 12. They will give you questions like C plus oxygen, then they give you what? CO2, like this. So C plus oxygen, a gas giving us what? CO2 carbon. Now they will tell you that calculate the mass of carbon. What were we doing here? If they say calculate the mass of carbon, what were we doing? Because I want you to at least to get the concept. When you start, they will ask you calculate the amount of mass of that produce. Yes, that product. So CO2, that is our product. Then C plus O, that is our reactant. Now they'll give you example. O2, it is what? The grams for O, which is 64 grams. Then they will tell you that calculate the mass of CO2. How were we calculating here? How were we calculating here? Then they say calculate the mass of here. What were we doing? The first thing which we are doing here, we were calculating the moles of this relating to this. That's what we're doing. We are doing that moles is equal to, yes. So that's what we're doing. Moles is equal to mass over Mr. That's what we're doing here. Then we are doing that mass. If we calculate the moles here, we replace 62. The Mr. of this is what? So 62. The Mr. of this is what? So here it is oxygen is 16. When you go to the periodic 16. So 16 times 2, which is 32. Yes. So 32 there. So what is here? Yes. Okay, it's here it's 64 grams. That's given us also. So here it's 2 moles. Yes. So 2 moles like this. Now, what were we doing to calculate the mass for here? We are just relating these moles to, we are relating to this. That's what we're doing. We're just relating these 2 moles. We are saying this, when it say it's 1 to 1, right? 1 to 1 here, because here it's not, it's balanced here. The chemical reaction is balanced. So we're saying 1 to what? To 1. That's what we're saying, 1 to 1 here. Yes. Then so this means that these 2 moles which we have calculated, it is the same moles for what? For the product. Yes. So it's the same mole for the product here, CO2. That's what we were doing. Remember, this is simple. So if we say that these 2 moles which you have calculated is the same as the moles which the product will have. Now what is the mass? We use the same formula. Moles is equal to mass over Mr. So use moles is equal to mass over Mr. Now, what is our moles for what? Our moles for E, for moles here. So we want to calculate mass. So mass is equal to moles times Mr. Moles times Mr. Like this. Now, what is our mass? So our mass here, we are saying that the mass, we don't know. We want the mass for this. The moles we have calculated is what? Because 2 for E is 2. Because it is the range is 1 to 1. That is the ratio 1 to 1. That is the ratio. So here will be 2 times, that is the more which is 2 which we have again. The mixture of this we are writing here CO2. Remember what we are doing here. Oxygen is what? Oxygen is what? You see, go on periodic table, which is 16. So 16, which is 32. Here, carbon is what? Yes, so carbon is so 12.01 like that. So 12.01. So then you were adding, yes, you add D, it gives you like 32 plus here, which is 4, yes, which is 44.1. Then the mixture which you found 44.1, then you calculate when you multiply 2 times 44.1, which will be 88.2. Yes. So grams. This is important because all the concepts in limiting reactant will draw all the concepts from what? From here, the thing which you are learning, because that's why I said to start answering any question in the exam, we just need to drive the concepts which you have already done. We are not changing anything here. I will also explain where the limiting reactant comes in. Even the percentage yield, those who have watched our video on percentage yield, we are doing the same thing. We are first calculating the limiting reactant, then we calculate the mass. Yes. Then we divide the percent. We find the percentage yield. Theoretical, yes, we divide by the theoretical yield. Then we calculate what? The percentage yield. So all questions in stoichiometry, all questions, they are simple and easy. We just understand the basic concept. So our basic concept here, it is moles is equal to mass times what? Mixture. That is the basic concept. Now here we have C plus O2, then give us what? This give us what? 12 gas. Now they are given us in the combination of here, it is 64 grams of oxygen gas combined with carbon. They will give you question 64 grams of oxygen gas combined with carbon. Calculate the mass of CO2 produced. How can you calculate it? That is what we did. We first found the moles. We have calculated the moles for oxygen here, gas. The moles we have calculated is 2 moles. Then these 2 moles, then we calculate also the moles for CO2. How can we calculate the moles of CO2? That's why it's when use the range. The range is 1 to 1 here. The range is 1 to 1, the range. That is the range. Now, if you know that the range is 1 to 1, then you create like this. 1 to 1. You say O2 is equivalent to what? To CO2. Then the range is 1 to 1. Then we replace here. Where O2, we have calculated these 2 moles, right? What is for carbon, which is X, like this. So what will be the carbon dioxide here? So X, that's why we did even the cross multiply, it's giving us which is X times 1, which is X is equal to 2. It is the same. That's why I said here the moles is 1 to 1 here. So that's why the moles for oxygen gas, it will be the same here, right? So that's why I multiplied mass is equal to moles times the mixture. So moles we have calculated which is 2. Even the mixture for here we have calculated. Remember what you learned this in grade 12. So we are just using the concept which you have to build you just using the same concept. We haven't changed anything here. So that's why we found to have 44.1. Yes, so 12.01, that is for carbon, 86.2 grams. That is what we did. So this is simple. Now my question is, how does, so my question comes in, how does limiting reactant comes in? How does relative reactant comes in here? Remember the first example which I gave you. I said you can't, like this product A. I said the first thing, this is product A or the solution A. You go in the labs doing practice. Then this is B. Then B here it is small. So which would determine this is product C. Now here my question is this question. Which would determine product C? Is it A or B? What would determine the product C here? Is it A or B? The question will comes to you, you say, maybe it is A, maybe it's B. Now, the question is, we don't do, in chemistry, we don't use maybe, I don't know, yes. But here you just need to know that since product B is small, product B, their main solution for A, then solution for B here. So solution B will determine the amount which will produce by solution what? C. Yes. So here, even as when we answered 82.2 grams, we were wrong. We were wrong. But why? Because we were assuming that oxygen, that is the limiting reactant. We didn't even consider for carbon. That is what limiting reactant comes in. Because we don't know the amount of grams which will produce here. CO2 which will produce here. We don't know. It is determined by the reactant. Is it the limiting reactant? Is it C? The limiting reactant, is it O2? What can we do to find the limiting reactant? Because here, even for this B, it will determine the amount of solution C which will produce. So solution C, if we are combined with solution C, yes. So we have measured that solution B is equal to this. So here, the solution, also the solution C which will produce, it will be little because it will follow the solution B. Yes. So that is the solution C. Because it will be little, but it will not. So here what will remain is what? Solution A will remain, but solution B will finish up. So solution B will finish up, but solution A will remain. Some solution A will remain, right? Why? So solution A, even though they are main, but they will remain like this because they are main solution what? Solution A. So here my point is, even here we don't know the amount of CO2 will produce. The grams of CO2 we don't know. Why? Because we haven't verified that. Is it carbon which will be limiting? Is it oxygen which will be limiting? Because carbon, if carbon will be limiting reactant, it will determine the amount of what? The product. Yes. So if carbon is a limiting reactant, it will determine the amount of CO2 which will be produced. I hope I have made it clear. So if you have questions on this, you can still inbox me 0762 514399 if you have questions on this. Let's proceed. So now, how can you find the limiting reactant? Limiting reactant. That is our first question. So how can you find the limiting reactant? Limiting reactant, we just find the moles. First thing, we need to find the moles for carbon, the moles for oxygen. In the question, they will give you example. Let me give an example. Carbon, they will tell you carbon here The grams for carbon, they will estimate, like, let me give an example. So which is 12.01, that is the carbon. Now they will give you, okay, let's give 12.01 grams. Yes. So they will give you questions. They will give you questions where carbon as grams, even oxygen as grams. Then they will tell you find the limiting reactant and find the mass produced by what? CO2. Or what is the grams which would remain for that limiting reactant? What is the grams which would remain unreacted? What should you do here? First thing, find the limiting reactant. First thing, we just need to do what? Find the moles. You say you start with carbon. That's so carbon E. What is? How do you find the moles? Moles is equal to mass over Mr. That's why I said this is the key formula. Moles is equal to mass over Mr. Any question they will ask you on stoichiometry, this is the key formula. So moles is equal to mass over Mr. So what is the mass? So the mass here they have given us is what? For carbon is what? 12.01. That is the mass. Now, what is the Mr. for carbon? What is the Mr. for carbon? When you go on the periodic table, you find the Mr. for carbon is 12.01. That is the Mr. for carbon. So the answer here to give you what? 1 more. So this means that here the moles available for carbon is what? 1. Yes, that's what it means. So the moles available for carbon is what? Is 1. Let's find the moles available for oxygen. So moles is equal to mass over Mr. Yes. So mass over Mr. That is the formula for moles. Now, what is our mass? So our mass here, they have given us is 64. So 64, which is grams. Then Mr. for oxygen gas, which is 16 times, which is 32. 32 grams. Now, what is it giving us? 32 divided by here, it will give you what? 2 moles. Here, so here, the first thing what you have calculated is what? The moles. Don't be confused here. The moles are variable. So moles are variable. So moles are variable. We have calculated it. That is the first step to calculate different equations. So the moles are variable for carbon is what? Is 1 mole, right? 1 mole. The moles available for oxygen gas is what? Is what? Is 2 mole. Now, so we have 1 mole is reacting with what? 2 mole. Now, my question is, which one is the limiting reactant? Men they will just go, it's carbon. Or some they will say, it's oxygen gas. Now, what can you say? Which one is the limiting reactant here? Which one? What can you say? The key there which will help you, you need to find the moles needed. So moles needed. So how can you find moles needed. So how can you calculate moles needed? So you just see here, just simple and easy. So you just need to find the moles needed. How can you find the moles needed? So just start with carbon to compare to carbon, right? So we start with carbon and carbon and chani. We are comparing carbon and oxygen. That is the first step. Carbon and the oxygen. Now we can start with carbon or oxygen if we want to find the moles needed for this reaction. So if we say carbon, we put here for carbon, we put X. So then we are calculating the moles needed for what? For carbon. Where so we just start we just write also the first thing before we put X. We just start also the moles relation. The moles relationship here. It is 1 to what? To 1 here. Now the moles relationship is 1 to 1. When you compare, you are just comparing oxygen and the carbon. So relationship is 1 to 1. Now if you want to find for carbon, the moles needed for carbon, we just put X. Then we use the moles available, which is what? 2 here. We just pick 2 here. We just insert 2 here. Then after inserting 2, then we just do what? Cross multiply to find the moles needed for carbon. So X, which is X. So giving us X is giving us 2. Now the moles needed for moles needed for carbon is what? Is 2. We have calculated. Yes, that is the moles needed. Now let's go to the moles needed for what? For oxygen. We just do the same thing here. We are not changing anything. Here instead here we just put the moles for what? For carbon, which is available. Then we put for oxygen is what? Yes. So we just do. So the moles needed we want for what? For oxygen. So just do the same thing we are doing here, which is CO2. Yes. So which is 1 to what? To 1. Now if you want for oxygen, we just put X here. Then the moles available for carbon, is 1 here. Then what is the moles needed? So we find X. So we're giving us what? It is 1. Here you have answered the question. We have done what? We have answered the question. What is the limiting reactant here? So the limiting reactant, how can you find it? And also if you are facing a challenge to find the limiting reactant, because I received many questions when I was in first year. I received many questions about calculating the limiting reactant. So many were confused. I don't know why. Because here it's just simple and easy. So I explained them. You need first thing, you need just the regular thing which we do. Calculate what? The moles. So you just use moles for here, even the moles for here. So if you calculate the moles, that is what we call what? Moles available. That is the second thing. The second thing is we just calculate the moles needed. Even the moles needed is simple. You just write a range. You have balanced the chemical reaction. You just write the range, what is C and O2. That is the key. You are relating to this to see what? The limiting reactant C and O2. Yes. Then you put even the moles which contain your balance here. If it's 1, you put 1. If it's 2, you put here. So here we just have what? Carbon here at first we add 1. Even oxygen we add 1. Then we are relating to each other. Like here we are relating. So what is X? That's why X is giving us the moles needed for Carbon, you put, even if it's carbon, you put X to carbon. If it's oxygen, you put X to oxygen here. You are just inserting the moles available which you have calculated. Yes. Now, there was also what happened one time. There was one person who able to answer this. But I asked him the question, what is the limiting reactant? Then he didn't know how to calculate the limiting reactant. It's just simple and easy. The only thing which will help you, if you can't able to relate here, the data which you have calculated, just draw a simple table which will help you. Like me here, I'm drawing a simple table. Then I write here. This will help you. But me, I know the limiting reactant according to what you have calculated. But for sake of debate, yes, we just write like this. When you write a table like here, you just put here, if it's O, you put O. If it's C, you put what? C, carbon, the reactant which is available in. Here we say moles available. Right? Available. We write the first table should be what? Moles available. Yes. So moles available. The second here, moles needed. So we do this. Then we just insert. We have calculated everything here. We just need to insert O2. What is our O2? The moles available for O2. You have calculated the moles for O2 is 2. 2 moles, right? You have calculated. What is the moles needed for O2? We have calculated also it's what? It's 1. We go to carbon. What is the moles available for carbon? The first moles which was available is what? 2. Which was, it's for carbon, it's 1 here. So we write 1. Then moles needed for carbon is what? We have calculated here, it was what? 2. Now, the question is, what is the limiting reactant A? Remember, the reaction here, the moles available, it is 2. You see here, the moles available, it's 2. But for the reaction to take place, the moles which is needed is what? It is just 1. So O2 is what? In excess. Let's go to carbon. Moles available is what? It is 1. The moles needed, it is what? It is 2. So if here it's moles available, we have 1 mole which is available. Then they say the moles which is needed here, it is 2. So carbon indeed is a limiting reactant. That's all. It just say carbon is the limiting reactant. That's all. We just interpret like this. They will mark you. The first question you have answered. So carbon is the limiting reactant. Now the question also which comes in is, what is the mass produced? What is the mass which will remain? How can you calculate the mass produced? That's why I said here, the first thing which we are doing here, we calculated the mass for this. We were wrong at first because we didn't know the limiting reactant. But since here we have known that carbon is the limiting what? Reactant. If we know that carbon is a limiting reactant, we can calculate successfully the mass for CO2. Why? I said if you have two concentration, which is A and B, I'll just repeat the same thing because I know because some people will be confused. Here we have 2 and B. I said if you have 2 solutions, A and B here. If we have this small solution here for construction of solution A, then we have many solutions for solution B. So you you want to make the chemical reaction A, what do? You just combine A. Since this solution A, they are little. So the solution C, if you want to calculate, you want to find the solution C, which you want to make. Yes, when in the lab, you want to make something, or you want to make any product, you want to make an acid, you want to make anything in the lab, or you want to make, even those who do some products, they sell some products, they do even say, they measure the solution A. Solution A, we have just little solution A. So just put the little solution A, then they'll measure what? To solution B, then they'll get some solution B in. So this means that solution A will determine the product of solution C. So here, even here, carbon is a limiting what? Reactant. So it will determine the product of CO2. Now, the question which comes in, calculate the mass of the product here. But even here, if they tell you what, let's start here. If they tell you find the mass which will remain. So how can you calculate the mass which will remain? So even here, let's give an example. I always give an example here. Then, what will be the solution which will remain here? How can you calculate the solution which will remain? So if it's solution B right here, you get some solution, right? When you get, if it's solution, the first initial stage for solution, the variable for solution B was E. Then after you get something, this is solution B, right? After you get solution B, it becomes like this. Now they'll tell you calculate the amount of solution B which will remain. What can, yes, so if you want to calculate the mass produced for CO2, right? So the mass produced for CO2, we'll calculate the moles like here for this. So when you calculate the moles, it will give you 12.01 over 12.01. It will give you what? 1 mole. So do mass is equal to moles times Mr. Because 1.
So pause the video, then you try to answer this question. Then you can send your solutions just to the number 0762514399. So anytime you are watching this video, just try to answer that question. Yes, the equation of the reactant of solution silver nitrate here. To answer this one, and this one. Yes, to be traced.